This session is going to look at correlation, particularly the Pearson correlation. You'll notice that the symbol for that is the lowercase r here. We use Pearson correlation with interval or ratio scale, so each of the variables should be on either an interval or ratio scale. And basically correlation, we're looking at the relationship between two variables. So the basic structure of the formula is the numerator is about the degree to which x and y vary together, and the denominator is the degree to which x and y vary separately. And so one of the things that we calculate that's a little new is the sum of products, and that's what would go in the numerator. That's the degree to which x and y vary together. And you'll notice this sum of products formula, I'm sure as soon as you saw it you said this looks just like the sum of squares formula, it's just that a y is in there, and if you said that, congratulations to you, you're very perceptive. That is the case. It's very similar to that. It's just that the y is in here instead of the other x. And so we'll be calculating the sum of products, and then you'll notice in the denominator we calculate separately the sum of squares for x and the sum of squares for y. We'll multiply those together and then get the square root of that. Okay. So let's go through a problem related to this. So this would be looking at screening for Alzheimer's. And if we've got if the normal screening is kind of long, then we have this long cognitive series test that you would take patients through for this. And so some researchers develop a 7-minute screen. So a much shorter version of this test to see if within 7 minutes we can give people a valid assessment as to where they're at, whether or not there's a potential here for Alzheimer's for the individual. So really what you want to do then is have patients who take both the 7-minute screen and the cognitive series, and you want to see what's the correlation between the two. And if it's a high correlation between the two, and if this cognitive series is already validated as being a good screen for Alzheimer's, and there's a high correlation, then the 7-minute screen we can say, oh, we can use this, we can save time, and use the 7-minute screen as a means of trying to determine whether or not somebody has Alzheimer's. So again, we'll work through our formulas here. So the first thing we're going to do is calculate the sum of products. Remember that this is the formula for that. Divide by n. And then we'll also be calculating the sum of squares for x and the sum of squares for y for this. So first off, a way in which we go about calculating these formulas, we would add up all the x's. So the sum of x, and if you do that, that's 63. If you add up all the y's, so we'll label this the x and this is the y. And this is 153. We add up all those numbers. Okay? And then on this side we go for each of these, when we multiply across. So 3 times 11 is 33, 8 times 19 is 152, 220, and so forth. 160, 56, 91, 36, 100, and 350. Okay? So we've got our sum of the x's, some of the y's, and then what we'll want to do for right here, notice this is x times y, and then we want to sum that up. So sum of x times y equals 1198. Okay, so again, to get this number we just added, to get the sum of x we added those up, sum of y here, the sum of x times y, we just added up all of those to get that number. So we have what we need to get the sum of products. 1198, and then 63 times 153, and we'll divide that by our sample size is 9. So 198, and then if we take 63 times 153, we'll get 9639. Divide by 9 minus we divide 9639 divided by 9, we get 1071. And our sum of products then equals 127. So we've got the degree to which they vary together in our formula. So a reminder, here's our formula for R, for the correlation coefficient. Sum of products divided by, and then we're getting the sum of squares of x times the sum of squares for y, and then we'll get the square root of that. And that'll be the degree to which they vary separately. So we've got our sum of products here. Next up for us is to get our sum of squares for x and our sum of squares for y. We've done that before. So sum of squares for x, remember, sum of x squared minus, and then the sum of x squared divided by n. So we're going back to this from our from one of the first lectures that we had, and I think I told you that we would keep coming back to calculating the sum of squares in that way. And so the sum of, we take each of these numbers, square them, and add them up. When we do that, we get 539. Okay? So at this point, if you want to pause the video and go and do that, go ahead and do that. But it'll be 539 when we take each score, square it, and add up all those squared scores. And then over here, right, we've got 63 squared divided by n. How do we get that 63? That's the sum of x here. We put that there, 63 squared divided by n, which was 9. $539 minus, and then we got 3969 divided by 9. 539 minus 441, and that gives us 98. So our sum of squares for x is 98. Okay? Sum of squares for y, we go through the same process here. So if we take each y, square it, and add it up, 11 squared plus 19 squared, so forth, we go through and do that, we get 2837. And then minus, and what we're taking 153 squared divided by 9. $153 squared gives us 23,409 divided by 9. That gives us 2601. And then our sum of squares for y then, 2837 minus 2601 gives us 236. Okay? So we've got everything that we need for our formula here. We've got our sum of products. We've got our sum of squares for x. And we've got our sum of squares for y. Okay? We put that in our formula here. R equals sum of products is 127. So that's the degree to which they vary, x and y vary together. And then we have 98 times 236, and then we'll get the square root of that. So 98 times 236 gives us 23,128, and if we get the square root of that, we have 152.08. $127 divided by 152.08, 0.835. Okay, so our correlation coefficient is 0.835. We can look this up in the back of the book, the table in the back of the book, to see if this is a statistically significant difference. So this is page 594. Critical values for the Pearson correlation coefficient. Our degrees of freedom is n minus 2 for this. So our sample size was 9 minus 2 gives us 7. And then if we set two tails, 0.07, our cutoff is 0.666. I've never seen that cutoff at 0.666. It seems ominous. 0.666, negative 0.666 for us. We're in here. We would certainly reject the null hypothesis, say there's a significant relationship between these two tests. The tests are statistically significant. That actually is a pretty high correlation. Remember, with correlation coefficients, they can go no higher than 0.1, or 1.0. They can go no lower than negative 1.0. And we can calculate then as well R squared, which gives us the explained variance between the two, the shared variance, if you will. 0.697 is R squared for that. So here, that's the basics of taking you through correlation coefficients.